Sean, it's great to have you here on Manufacturing Happy Hour. This interview, I feel, has been a long time coming. And the first question has to be, if we were having this conversation over a beverage, where in the world would that be?
I got two places, but if I was to favor one, I'd probably jump right into Joost van Dyke in the British Virgin Islands having a painkiller on the beach. My sisters live on St. John, which is the island right across the street, right across the water. And I've been there many times. Beautiful place of the part of the world. I mean, it's paradise, and it's a lot of fun.
Excuse my ignorance, but what is a painkiller? I don't know if I've heard of that
Or
drink
is
before.
rum, is dark rum mixed with a bit of pineapple and orange juice with nutmeg, and it's a concoction that was invented actually on Joost van Dyke, and it's really good when you start getting used to them.
All right. Well, this might be the first time we've had a conversation like this over painkillers, then, the beverage you just introduced me to. But if we're having this conversation over drinks on the beach, explain to me how panel design is groundbreaking, as if we're having a beverage with one another.
Well, panel design has been traditionally kind of a means to an end because, I mean, the most important aspect of the panel design is really the machine, right? You have to build the machine defines what the function's going to be and what products are going to be produced. And then at the end of the day, all of those electrical components that manage the machine and make it work, they just put them in a box somewhere to protect it from getting electrocuted from danger specifically. So it's more of a kind of a lot of these years has been more of an afterthought, in terms of looking at the machine production, things like that. However, in recent times, again, time is money, and if the machine fails, you need to troubleshoot the machine. So where do you start? Well, typically it's the electrical system that fails. So how do you go about troubleshooting that? And now you're going to look for components in the control cabinet. So now the emphasis over the last years, and not just 10 years, probably 20 years, has been, let's design these control cabinets really well and make sure the components are laid out correctly, make sure that they're labeled correctly, make sure that you can test them quickly and find your faults and things like that. So an emphasis really has kind of shifted from the panel building to the troubleshooting aspect. And in the troubleshooting aspect, the panels have been a key component of that. But the traditional way of looking at them has, I think, enhanced and become a lot more important. Specifically in the design and build of control cabinets.
And we're going to dive into the nuts and bolts of this later on, right? Designing for troubleshooting versus the design of the panel itself. But first, you have a fascinating story that we need to touch on first. And I'm just going to start off with the timeline that you shared. And please correct me if I'm wrong on this, but you were born in Hamburg, Germany. You grew up in Basque Country. And when you were going back to Germany to start your career with EPLAN, but you've spent most of your, the most recent part of your career here in the States. Is that generally correct?
That is absolutely correct. So I'm a true hamburger. And funny story about hamburger, and I'm not sure what the actual origin of the hamburger is, but one of the myths is that it started in Hamburg, and originally it was a piece of fish in between two pieces of bread. And it was called a hamburger, and they used to eat that at the port of Hamburg. And I don't know if that became the official reason why we call meat in between two pieces of bread a hamburger nowadays. And then I moved from Hamburg to the Basque Country, where I grew up for 14 years. And it's a beautiful part of the world. A quarter of it is in France, 3/4 are in Spain. It's a region right in the middle of the Pyrenees. And I grew up there as a farmer. I mean, I grew up there as a farm. And the Basques are absolutely fantastic people, and one of the ways that I always use to describe the Basques and how great they are is trying to sell calendars. So I used to play soccer, and I had a soccer team, and to raise a bit of money, we would go and sell calendars to the villagers, and they would just give you, 10 francs at the time or 20 francs, depending on what they could afford. And I was never able to do more than 10 houses, 5 houses actually, 5 was pushed, maybe three to 5 houses per day selling calendars. And so it took me nearly a month to complete my calendar sale throughout the village. And the reason is every single house you'd go to, they would invite you in. And if you didn't have something to drink and something to eat, they would not buy a calendar off of you. So by the time you got to the third or fourth house, you were completely drunk and you couldn't continue selling calendars. But it was really, it's just the characterization of how welcoming the Basques are, and they really kind of put that aspect on personal contact. They want you to sit down, they want to look to you in the eyes, they want to talk to you, they want to get to know you, and it's how I kind of grew up for 14 years, and it's been a fantastic experience.
I want to ask you a bit more about your experience selling calendars in Basque Country, right? Because you'd kind of given me the Cliff Notes version before the interview, right? How did that experience impact you? I mean, I feel like everyone's early, let's say, career or sales experience kind of has some lasting impact. Can you share some of the lessons you learned from that have stuck with you in your career?
Absolutely. The bigger picture in the calendar selling aspect was really my godfather and my godfather's family. They were farmers. And I used to get up in the morning and go to school and come back, and I would just drop my bag, get into my blue overalls, and then start working the farm. And I would drive the tractor, feed the cows, and then work the farm. And it's such a tough job, but it's very rewarding. When you see what you've done accomplished at the end of the day, you've plowed the whole entire field and you can see it done. And it really teaches you respect. It teaches you time, how to manage your time, be on time, make sure that everything's done correctly on time. It teaches you responsibility because the cows never go on vacation. You have to feed them every day and things like that. So it kind of really helped me to grow up in a much faster way than I would say if I was in a city technically, because the responsibilities were there whether you wanted them or not. And you got to grow up and enjoy them at the end of the day. So I think that was an important part of my upbringing and it's funny because I say certain countries, they send you when you turn 18 to the military. And I think they should change that around. And I think every single kid growing up should be sent for 6 months to a farm. And it really teaches you enormous values on life, on a whole bunch of aspects that are incredible and important for the rest of your career.
I love that story. As an aside, Australia has kind of adopted that mindset a little bit because when Americans move to work, like live in Australia for an extended period of time, if you're there on like a temporary work visa, you have to work on a farm for part of the time that you're there. I know that because my sister went through that experience, but I love that lesson. There's another part of your story I want to ask about as well, was when you went into your trade, right? Because if I remember right, you originally wanted to be an electrical engineer, but you actually went the apprenticeship route instead. Why did you take that path?
Correct. So it kind of I finished my education in France, but I was in Germany at the time. I was going to a French school, and then my next step would have been going to university. And that's where I wanted to follow the path of electrical engineering. However, due to my grades, again, maybe not paying as much attention as I should have back in the days, I had a 4-year waiting list. And the option was to do an apprenticeship in Germany. So they said, if you do an apprenticeship for 3 years in Germany, they'll knock a year waiting list off of your waiting time. So once you finish your apprenticeship, you can jump right into your studying course. So I applied for an apprenticeship and I got it at EPLAN as a computer science and business management apprenticeship. And the beauty of that apprenticeship in Germany specifically is that it's half at school and half at work. And when you're at work, they kind of force you to go to all of the different departments in the company. So you go through order processing, you go through financing, you do HR, and every time it's like 2 to 3 months at a time. And depending on what your strength is, so for me it was computer science, so I spent a lot of time in IT. So I was doing all of the IT networking and helping out with our software tools that we offer at EPLAN. And that's kind of how I grew up, was doing the apprenticeship. And at the end of the apprenticeship, I loved the software, I loved the tools, and I didn't really want to go back studying. And I just jumped right into EPLAN and to get to understand what EPLAN was. And then from there, I kind of took it on. And for me, it was computer science, and EPLAN is nothing else but a database. It's data management. So for me, I kind of understood the principles of it, the structure, and afterwards it was just getting to know the trades better, and that's what I learned at the customer side and through my experiences over the years.
We're going to spend a little bit of the conversation on this topic because it's super timely, since I think we're seeing it trades are in vogue right now. It's not the, oh, you have to go to college and get a 4-year degree. We're definitely shifting more back towards, hey, trades are a great path that people to go. So your apprenticeship experience, I think, can be something a lot of people can learn from. And my first question, I guess my first follow-up question, you touched on this a little bit, but if you could answer really directly, why was an apprenticeship path the right path for you?
The apprenticeship was the right path for me because it gave me the theory of school because I was going part-time at school, so understanding the theoretical aspect and the logical deduction aspect, but it gave me the practical application. And it really was helping me to understand, how does a business work? How do we sell solutions? How do we support solutions? How do we train them? What is a customer? How does he behave? And how do we interact with him? And how do you develop, how do you grow your business? And I thought that was really, really cool. And I love that because it was very practical. If you go to college, I mean, granted, you can do little stints here and there, but it's just very theoretical. And at the end of the day, you really don't have that experience that you get through an apprenticeship, which is hands-on, getting your hands dirty and grabbing a screwdriver and connecting things together. And I think just even those mechanical motions that you do in an apprenticeship are just so undervalued. And they bring such a tremendous amount of experience down the line that you can have complete different conversations with customers.
So another question I have then is, EPLAN still does apprenticeships today, as I
Yeah,
understand it. Can you
absolutely.
tell us a bit about those?
So every year around, I think, September, that's why I started back in September 1993 at EPLAN. In September, they have applicants, so you apply, and they have different positions. So you have whether you go into computer science. And I think the majors or the curriculum has changed over the years. So you're depending whether you want to go more on a sales apprenticeship or you want to go more on a management apprenticeship or more on a commercial or even technical apprenticeship. So they've got different packages, and each company decides what package they want to offer. And then people apply to them, and then every year in September there's a group of apprenticeships that starts at the company.
So maybe a question to wrap up this little segment is, I mentioned that, hey, trades, apprenticeships, people are starting to look at those as, their career path earlier on at this point in time. And I'm curious, how can people determine if an apprenticeship is right for them versus maybe getting an engineering degree?
I mean, an engineering degree is always useful when you start going into R&D development, things like that, because you really learn the little bits and bytes. But around R&D, every business, every company has a lot more to offer, and you have that opportunity with the apprenticeship to go into those other areas and grow and define your own path. I kind of equated a little bit to Montessori, the teaching habits where kids kind of develop their own little skills and figure out what they want to do. Well, if you start an apprenticeship, you've got a general idea in which direction you want to go. But once you get into the business gives you those opportunities. Do you want to go more into marketing, into sales? Do you want to go more into order processing, things like that, depending on your skill set. And I think it really helps to develop a person without forcing them into going into a specific direction.
I love that answer because I think I'm a degreed engineer. That's my background. Admittedly, I haven't really been an engineer since then, but I always think of engineering as the value of problem solving and opening up doors for you when you enter your career. And what I heard from you is, hey, apprenticeships can provide those same door opening experiences, right? You can get in there, you get your hands dirty, you get to experience things firsthand, learn on the job, and then you still have a ton of opportunities ahead of you. It's not just, hey, you are in this specific field, this specific trade forever. Did I hear that right?
Absolutely. And then another thing I'd like to add is companies sell products, right? So at the end of the day, when you hire somebody, I think the most important aspect is the personality. You're hiring the person for who they are. You can teach a product, but you can't teach personality. And then your personality and whoever you are can also develop in those various different aspects of the company. Whether you're more a numbers person, you want to go more into accounting, or you want to move into finance, or you're more a creative person, you've got the marketing division, you've got sales, if you're more an outdoor person or an extrovert, you go into sales. So that kind of helps you to, even though you set up on that apprenticeship, you have the ability to grow and develop into your own set of skills.
And I've got just a couple more questions around your career background before we shift the conversation to panel design. But we said it at the start of the interview, right? You're a Hamburger. You grew up in Basque Country, jumped back to Germany. You're over in the States now. I mean, really a general question around your background. How has your international upbringing shaped your worldview in general?
Oh, hugely. I mean, again, you listen to all of these conversations today, and you listen to, how race plays a role here and there. And it's like, I don't see race, I see people. And I always say, it's like, if you're an idiot, I don't like you, but you're an idiot. And I don't care what color skin you have or what your background is, because I've met idiots all over the world. But I've met some fantastic people all over the world too. And this traveling really has got me to interact, and I really got to love that aspect of traveling, is understanding the culture, how they think, why they do things the way that they do, and not criticizing it, but accepting it and taking the benefits out of it. Instead of looking, it's like, oh, I remember the first time I came back from Germany over to the US, and I fell into the trap where it's like, oh, why do they do things like this? Oh, they do things like that. In Germany, it's much better. Oh, in Germany, it's much better. And I was like, no, it's different. It's not better. It's different. And then I kind of changed my tone, and suddenly I was able to appreciate things here in North America much easier, much better, because they do things the way they do, and they have sense. They make sense. And depending on what you're dealt with and what environment you grew up in, it's like that's what you have at your disposition. And I think it's great. And to be able to travel and learn all those things, I think it's fantastic.
And maybe a more specific spin on that question, since we have a lot of manufacturing and just a lot of leaders in general listening to this show. How has your international upbringing shaped your approach to work specifically?
It's the international upbringing has helped me kind of take the best of all the worlds, because if you look at, again, I can talk from Germany and the US. And in Germany, it's very methodical. It's very, you have to work everything out before you can start developing a product. You have to figure out all the quirks, and it's very methodical, and it's great. But it takes a while to get anything done because they have to figure everything out first. You go to the US and it's just like, let's do it. Let's get it done. Let's start. I haven't figured everything out yet, but I'm just going to start and make it happen. And I think, from looking at those two perspectives, I think the best of both worlds is combining the two together and having a guy that just wants to, like, let's get started, but let's put a plan together. Let's figure out what do we need to figure out first. And at the same time, let's start a rough draft. And kind of combining those two skills together would be probably, from my perspective, the ideal approach. But it's interesting to work and to see how they approach a solution in different ways. And same thing is true for the control panel build, right? So the way that they design a control panel in Germany, it's very methodical, and here in the US is I just need to put things in a box and let's put things here and stuff like that. But now they're kind of realizing that they need to kind of combine the two together.
Yeah, and I appreciate you being so open about your journey, the things you've learned. I think we got a lot of great insights there around apprenticeships and, just the lessons of what it's been like really seeing the world like you have. And I think you provided a perfect segue into this part of the conversation where we shift more towards talking about panel design and the methodology that goes into that. But first question, when you've spent your career looking at schematics for as long as you have, this is another drinking beverages on the beach type question. How do you keep it interesting, right? I mean, it's schematics, right? So how do you keep that exciting after all these years?
Yes, the fascinating, and I looked at it as well from my perspective, and at the end of the day, I sell a software solution, or we provide a software solution to schematics, and the schematics in and out. But the interesting thing is what our customers do with it. And every customer I go visit, they build different machines, big machines, small machines, fast machines, slow machines, all sorts of different products and different ways of, and they're very proud of the products and the machines they build. So every time you go visit a customer, they'll take you behind the scenes. And I remember one of our customers, it's like, I don't think I've ever spent that much time looking at a roll of toilet paper, because they had the machine right next to it that would make that roll of toilet paper. So suddenly you look at how many plies they are and how fine and how everything was cut and how fast that toilet paper roll was produced. And it's fascinating. And it's pretty much every customer is different. And that's what makes it so interesting. At the end of the day, the schematics are a means to an end. And it's just helping the customer use that mean to be able to be more productive, more efficient. And it's a good environment to be in. I really like it.
And we're going to be talking about schematics largely in the terms of like panel design today. So, I want to talk about data-driven design, but I think we got to take a first step before that. Can you tell us the core steps that go into a proper panel design methodology in general?
So you have, of course, you have the ideal one, but I'll talk about the traditional one. And the traditional one has been you have a set of schematics, which is kind of your core documentation of your control systems. And then you take that schematics and then you interpret that schematics and understand what needs to go in a panel, which panel do they go into. And then you start laying out your control panel, understanding what size it needs to be. And all of those decisions are made based off of the schematics. And the way that the control panel is built is, again, reading the schematics, but the schematics are geared towards the panel build. So you lay out your schematics in a way that it's very easy and fast for the panel builder to understand how they're put together. So you'll kind of put all of your power components together, you'll put your control components together, all of your PLCs, you'll group them together because they typically have the same wire size. And then you'll try and group everything according to devices. So you'll have one big device with all of the wiring going into it. And it makes the schematics very easy to use for panel building. But now when you pass the panel build process and you go into the maintenance aspect, it makes it really challenging because all of the documentation is all across the board. You have a motor on page 2, you have a PLC on page 20, 21, 22, 23. You have the control system on page 10. And you constantly have to navigate through all these pages just to find and troubleshoot your specific function. So today, traditionally, the schematics have been designed or are designed to build the panel. And that's it. And if you look at all of the aspects behind the panel build, which are maintaining the machine, installing, commissioning, doing all of the troubleshooting at the end, it's a huge aspect that's being ignored, I think, today from a panel design perspective and from a controls design perspective.
Well, we're going to dive into that a little bit more, but first let me shift to another side of the table, right? Data-driven panel design. Yeah. I think there's a precursor question to this because you've spoken to me a little bit about this before. When you're talking to a manufacturer, why is one of the first questions you ask them, hey, how does data flow through your company, right? I'm not sure most people think of that as like a first question when you're talking about a panel design, but why is that the way you start your conversations?
Well, typically when you approach a customer and you say, oh, here's EPLAN, it's a tool to design schematics, and then they'll look at how do we design schematics today, and they'll do a one-to-one comparison. And they'll see, well, this can do this, we can do that. Well, it's kind of, we do schematics today without your solutions. Why do we need it? Well, I basically take a step back and it's like, how do you get the information that you need to create that schematics? Where does it come from? And then they'll say, oh, we've got an Excel list, we've got a bill of materials, we've got an IO list, we've got an instrumentation list, we've got a motor list, we've got a sensor list. All of these lists are created from Excel. And where do these lists come from? Oh, well, we've got some designs in Visio, we got some in AutoCAD, we've got some in various different tools. And then once you start looking at that, you've got multiple different tools. And then you've got the same information that's copied from one tool to another and maybe modified here and there. But the copying of the data goes through every single step. And it's a challenging task because you never know, is it up to date? Is it the latest version of the data? Who edited it last? Did they remove this, for example, set of motors or not? And all of those questions are unanswered, and people just get handed these files with data on them, and they just have to translate that into designs. And it's very challenging. So that's why I take a step back and I look at, okay, how does your data flow through the company? Let's say you need a motor for your machine. Where do you define the motor? Okay, it's the mechanical environment that defines it. Okay, how does that information gets transferred to the schematics guy? Well, we create an Excel sheet and he reads that and he puts that in there. It's like, okay, why do you create an Excel sheet? And then, well, because we don't have a tool to be able to carry that data across. And this is where I kind of translate that workflow and how the data flows through the various different engineering departments all the way to the machine build or panel build. And I look at how can we streamline that process so you don't have to enter the data multiple times, so you don't have to duplicate it, and you don't have 15 different sheets that are available for every department to kind of feed off of, which creates more work. And that's where I think looking at the flow of data through a company and through the different departments is incredibly important. And that also means that you need to talk to the right people, because every department is always focused on their task, right? You look at the electrical engineering department, they're not going to go overboard to try and satisfy the needs of the mechanical department or the maintenance team. They're going to do the work that they need to do. But now if you look at it holistically, and you start looking at how can I optimize the flow of the transfer of data across, then you have a different conversation. And then you can look at different tools and better tools to handle that.
So I feel like we've kind of touched on the first step of data-driven panel design. Can you share what the rest of the methodology looks like around data-driven design?
Yes. So data is not necessarily data, right? So you have, like I explained, you have a data, for example, on the mechanical side that gives you the mechanical aspects of the motor. Then you have the data on the Excel sheet that gives you the motor, the part number, the commercial data. Then you go into your wiring diagram. You've got the data associated to how do you wire that connection point. Then you have that same information, for example, for the contactor into the control cabinet. Where is it positioned? How big is it? How much power dissipation it have? So different departments and different engineering tasks have different requests for data. And the idea of a data-driven system is to provide that one object and provide all of that data surrounding that object at any point in time so people can just feed off of it. So you know you have this motor, but why not start defining that motor with all of the required data? You know the size of the motor, you know the mechanical layout of the motor, you know how the pins are connected to that motor, you know what the power dissipation is, you know what the horsepowers are. So all of that data, you can capture it and create an object out of that. And then when you design, then you have different representation. You have the mechanical view, you have the schematic 2D view, you have the wiring view, the cabling view on that same object. And those are all just different views on the same data. But at first, you have to have that data to be able to leverage.
So another question I have, and this is from the perspective of someone like myself that's worked in Houston, Texas, and San Francisco, California. A lot of people are very focused on the differences about their unique vertical, right? It's like, oh, well, I work at a chemical plant, or I make cars, or I make hot dogs, whatever the process is, and they think there's something, and not to say there's not something special about all these processes, there are, but I feel like a lot of people use it as a way to be like, oh, well, this methodology won't work for us or something like that, right? So can you share how this methodology is similar across all types of verticals?
Yes, because we don't look at it in the traditional way. If you look at the way you just described it, it's like, yeah, they look at the machine and the way the machine works, and that has to do with the mechanical aspect. I take the mechanical aspect out of the equation, and I just look at the controls. So when you look at controls, if you have a machine with 5 motors or 10 motors or 50 motors, at the end of the day, you have a motor. So why not define the motor as an object with all of its information and then just duplicate that motor, change the parameters, but still use that same object? And from a design perspective in the electrical side and the control side, there's really not that much difference. It's just the size of the motor changes, which means maybe the size of the wire, the cable, and the protection device. And maybe at the end of the day, you need a bigger control cabinet or a smaller one. But the environment where we're in is very similar. So even though they can have completely different machines, from a controls perspective, it's really more or less the same. You got 10 motors or you got 5, and you need a safety circuit or you don't. And it's just here the little options that change. But it makes it actually really easy to kind of standardize, which is a huge key component of controls design.
Well, I think this next question I'm going to ask you, we've touched on in a number of ways so far, but I'd love to kind of summarize things around a story and one of the core tenets that I understand from you about panel design. Why is this methodology so important, right? Maybe you can share this in the context of designing for building a panel versus designing in order to troubleshoot the machine.
Correct. So let's take a look. Let's again step back and take a look at the life cycle of a control panel. You have the design of the panel, and then you have the building of the panel. And that takes anywhere between, a couple of weeks to 6 months to maybe a year. But now you integrate that panel into the production process, so the manufacturing facility. Now that panel is running, and they're going to produce product for years and years to come. So the difference between the designing to build is a lot shorter than designing to troubleshoot, because you can troubleshoot that motor for the next 10, 15, 20 years to come. And that production environment too has a huge different leverage, or big different leverage compared to manufacturing. Because what if the motor fails? Well, the whole production facility stops. That means the company is suddenly losing a lot of money on a minute by minute basis because that motor is not running. And to troubleshoot that motor, you need schematics. And if the schematics are not helpful for you to troubleshoot quickly and efficiently, then again, you're going to lose more money because the machine is not going to be fixed on time. So this is why if we change it around and we say, okay, let's design to troubleshoot. So that way the documentation, when we deliver it to the customer, they open up the panel and they can troubleshoot a motor with all of the components associated on one page and quickly access that information and troubleshoot it in minutes instead of hours, then that's a huge benefit. And now let's take a step back and see, okay, now we've created the documentation for troubleshooting. How are we going to provide the information for panel build? Because if you ask a panel builder to read the documentation defined for troubleshooting, he's going to have a nightmare. It's going to be great. So now we're going to say, okay, let's take the data, again, because it's a data-driven system, and let's shuffle the data and present that same exact data, not in a schematic fashion, but in tables and lists that he can use to simply quickly wire a panel, to quickly place the components on the backplate and commission that panel. But he doesn't have to do it off of the schematics anymore. He can do it off of documentation that was provided or generated for him based off of that troubleshooting documentation.
Yeah, the way I kind of hear this is it's designing for the future, like troubleshooting and having it out in the field, versus designing for the present, getting the panel built and out the door.
Exactly. One doesn't have to exclude the other depending on how you start. If you try to design for building the panel, then you put yourself in a corner where you can't get out of anymore because the troubleshooting will always be a challenge. But if you design for troubleshooting, now you can use that troubleshooting data to generate the information for building the panel, as well as making it available for troubleshooting. So you're kind of opening your path for a kind of future-proof approach.
Yeah, this was super helpful, and it actually spurred a couple other questions that I have in mind now. How many, if you just, you don't need exact numbers, but out of all the people out there that build panels, are systems integrators today, how do you think the majority are building it for or designing for building the panel, or do you think most are designing for troubleshooting? What do you see as someone that's been in the field as long as you have?
Unfortunately, I still have to say, I think it's still around 80-20, maybe even 90-10 of designing for building the control cabinet. Because it's always comes down to, I don't have to do this because it's not my job. So it's not my job to troubleshoot the panel down the line. It's my job to build it. So I'm not going to go over, above, and beyond or change the ways I do things just to satisfy somebody that I'm not going to make any money off of, basically. And that's where also kind of taking a holistic approach and looking at like the different players, the operator, the machine builder, the OEM, and then the panel builder, kind of working together changes the dynamic of the information being provided by each one of them. And if you can work towards the end goal, which is helping the operator troubleshoot efficiently, then you look at the building process of your control system differently. And if you can change things around, and it requires change, and unfortunately it is so, and nobody likes change. I've been doing this for 20 years, and we've been making money doing this for 20 years. Why should we change? Well, you'll have the guy around the corner that is going to change, and you're not, and he's going to overtake you really quickly, and you're going to be out of business. But they don't see that in the short term, so they don't necessarily see the urgency of change, but it's coming.
And I was just asking that question from the perspective of like the panel builder, the system integrator. I'd like to actually flip that. Do you coach end users, manufacturers to ask the question of panel builders and designers to say, hey, are you designing this for something that's going to be helpful to me after you walk out the door, right? Or are you designing this so that you can get this done and into my shop as quickly as possible and move on to the next thing?
We try to, and that's a great question, because I've interacted with quite a few operators and communicated that message, and it's always, again, for them a challenge. It's like, but I can't tell my suppliers how they have to do the job. And if I tell them, it's like, okay, now they have to invest, in more software solutions or other tools to be able to fulfill my requirement that's going to help me. But what they don't realize is it's going to help them as well. So it's really, it is an education program that is not necessarily starting at one particular point. It's everybody along that supply chain that needs to be involved, from the end user operator to the machine builder OEM to the panel builder. And then once they understand the whole flow of information and how it's going to help each and every one of them along that process, then they're kind of more willing to change. But initially, it's tough to get them isolated and to kind of get the other people to change. It's really a collaboration initiative that needs to be started.
Well, one of the takeaways that I'm hearing from this is for, let's say, the controls and automation segment of our audience, and there are a lot of them out there. Like this, the things you're bringing up sound like great things to whether you're designing the panel or whether you're the one responsible for purchasing it and maintaining the equipment long run. These are great things to be asking and keeping in mind early in the process, so that way you can, essentially do your job better, serve your clients better, serve the factory you work at better. All those things are things that I've heard from what you're saying today.
Absolutely, absolutely. And again, it's a mind shift. The only constant is change. So and the world evolves. There's new technology coming out, and it's trying to stay on the forefront of technology, looking at new options and never staying put. It's always looking at new opportunities to make a panel build better. And I've been talking with panel builders recently, and they've made that change. Initially, they were like, "Oh, but I have to invest in these machines. I have to invest in this software, and it's going to be a lot of money. I don't have that budget." But when they start looking at the amount of leverage they can get out of it and how much the ROI is really, really short, and then they start implementing it. And that's why I like the kind of American way. It's like, let's go and do it and let's get it done. And then they just push the people to change and force them to do it. And then it's incredibly successful. And they just realize how much time they were wasting doing it the traditional way versus kind of making that switch and going to a data-driven engineering aspect, right?
Yeah, I think our audience knows that change is a challenge, but if you get the right leaders with the right vision in place, you can make those things happen, like you're saying. So, we're getting towards the end of our conversation, and I've got another question related to this because it came up in our pre-conversations when you and I have spoken before. But I think schematics are a great reason for me to ask this question, right? What is the difference between digitization and digitalization? I think you've got a nice definition that separates the two. And I know that's something that for manufacturers out there isn't always clear.
Yes, and it comes back to drawings versus data-driven environment, right? So I like to use the example of a scanner. You scan a document, and now that document, you can visualize it on a computer, but you can't really do anything with it, right? So it's just a bunch of pixels and it shows a pretty picture. And for me, that's digitization. You just scan the information and you make it digital and it's just ones and zeros, but there's not really any correlation. Now let's drop an OCR tool on top of that document. Now it identifies the words, and now you can take a word or a paragraph out of that document. You can translate it. You can copy and paste it into different documents. Now you have data, and that data can be used for creating additional documents. So now you didn't just digitize it, you digitalized it, because now you are adding more depth to that digital information. And that's the key difference between the two. And that's why I've been working on our marketing department to like, hey, don't use the word digitization, because we are working on digitalization. Everything we do is data driven, is data objects that contain a lot of information that you can leverage for improving your panel build, improving your troubleshooting, improving your design environment, better collaboration, and things like that. So it really has to be at a data level versus at a digitized level, which is just a pretty digital picture that you see at the end of the day. So very important distinctions between the two words that are today kind of interactively used, but there's a very, very strong difference, and digitalization is the way forward.
Yeah, when I think it's the easiest way I think about it is like, right, that CAD file where, hey, one looks pretty, but it's not functional, whereas the other is functional. You can still do something with it, which is, hey, digitization versus digitalization right there.
Absolutely.
So, couple final questions, and this one's a bit of a personal question, and I've asked this question of my guests before who have a lot of longevity at a single company, and you started your career decades ago in the apprenticeship program at EPLAN, so it's a pretty straightforward question, but I have to ask, why have you worked at EPLAN as long as you have?
Well, my simple answer is, or actually, I should probably, I'm going to steal this. I think it's a quote, but I can't remember who said it. If you love what you do, you don't work a single day in your life. I've been on vacation since 1993, and it's been a blast. It's just one of the key aspects in my career at EPLAN is is seeing the smiles on my customer once I've done a week-long consulting and implemented EPLAN, and seeing all of the tedious things they used to do before, and suddenly it's just a breeze and they really enjoy it. And then you come back 6 months later, it's like, okay, I'm gonna take EPLAN away and go back to the old ways. And they say, no, 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 I refuse to. No, I want to move forward with this. This was the right change. And it becomes more of a partnership relationship than just a customer relationship, because you're really helping them do their daily job faster, better, easier with the right tools, and taking a lot of the headaches that they used to have away. And it really kind of builds these relationships. And now I can I've got dozens, if not hundreds, of different customers that I can call up and talk to them really at a personal level and meet up with them. And I built a lot of relationships over the years, and I think that's been a key component of EPLAN. Just not only the solutions they provide, and also the hiring practices that we've had internally at EPLAN for decades have been absolutely fantastic. I mean, we've hired people from various different creeds and backgrounds and personalities, but when you look at the family, they always fit together. It's like you've got, different characters that are always kind of in. And before the pandemic, we were meeting like once a year at our global sales meeting, which was fantastic, because you'd meet the guys from South Africa, from Malaysia, from China, and you could talk to them, have a beer, and exchange information and ideas. Unfortunately, the pandemic has kind of squashed that a bit. So that personal relationship is not there anymore, but I think it's going to come back, and it's been fantastic, and I absolutely love it.
Yeah, I think it is coming back. I love that line. You've been on vacation since 1993, and I know our audience knows that you haven't just been drinking cocktails on the beach since 1993.
I've had the odd one here and there.
Yeah. No, this has been a lot of fun, Sean. One final question. I shouldn't say one final question, but I always ask this one as well. Is there something you wish I would have asked you that I haven't in today's conversation? Anything that's come up? Anything that's still on your mind?
Yes. I think again, it's finding the passion in what you do, and it doesn't, unfortunately. Not everyone always finds the right path, but it's never too late to change and to turn around and to move along. I was fortunate enough to kind of forge my own path and find a great company to work for, and still working there. But if you don't, it's like, don't be afraid of saying, hey, let's just change it. And it's not for the worst. It's a lot of times it's for the best. And on top of that, if you have the ability to have people around you that can identify what your talents are and help you in those career moves, the better. But don't be afraid to ask for help. Kind of. I think those are kind of key components of a healthy life at work, I would say.
It's funny, right? You've jumped around the world. You work with manufacturers to help them change and evolve the way they do their panel design. When did you start getting comfortable with change, right? Or what makes you comfortable with change? I think that's something that a lot of manufacturers aren't necessarily comfortable with, but you seem to have a knack for it.
I think, and I'll go back to our initial conversations when you were asking, you've traveled all around the world. And I think the travel really opens up your eyes and makes you less afraid of change. And I see that in the personal life too. If you live in the same city for 20, 30 years, and all you see is that same bakery and you see those same people, and you kind of like get into this mode where the comfort zone, right? And you don't want to kind of change because you like what you have, but you don't know what's out there, and you don't know how much different and better it can be. Like the loaf of bread, you go to France and you have a cup of coffee on the Champs-Élysées and with a piece of bread, and it's just a complete different experience. And it changes, and it allows you to grow as well. It allows you to open your eyes and to accept change as a normal matter of moving forward, and not being something that's tedious and that's always kind of tough to do.
Well, I was going to have everyone have the call to action from this episode be, hey, rethink the way you're doing panel designs. Hey, look at apprenticeships. But I have a feeling a lot of the people might go get their passports stamped after this.
I think it's a key component of that is just to open your eyes on various different things. Yeah.
I love it. Well, this has been a lot of fun. Last question. What's the best way to connect with you, Sean, as well as EPLAN?
Well, with me, there's my email address. I think you're going to hopefully publish it in the bio, so you can reach me via my email. EPLAN, we've got a website, eplan.com or eplan-software.com. You can go and visit us, and depending on which part of the world you are, we've got various different locations you can connect to. And we are more than willing and more than wanting to help you change and become a lot more efficient in your panel building process and streamline your data-driven approach.
Excellent. Well, I'll make sure there are ways to connect with you, connect with EPLAN over in the show notes page at manufacturinghappyhour.com. And with that, I have to say, cheers and thank you so much for being on the show, Sean.
You're welcome. My pleasure. It's been a great interview. I had a lot of fun.